This webinar, as Sarah alluded to, is for C2I. It comes from a customer question. He wanted to know a little bit more about how to model C2I interference in ATDI planning tools, what C2I means, and the type of technologies that it's going to be used on. So without any further ado, let's begin. So what are the aim of today? That's to show users how we can model interference from a carrier to interference perspective, C2I. And who should be listening in? Well, any RF planner or spectrum manager. So what will we be covering in this webinar? What is C2I? A brief outline of what exactly it is in theory. What type of radio systems would use this as a measurement? How would we set up ATDI planning tools to actually be able to calculate the carrier to interference? Masks, what are they, and what type of masks are available within the ATDI planning tools? Well, first of all, C2I, what is it? As its name suggests, carrier to interference. Now, all radio systems will need to have a certain signal to be able to function, and within certain systems, providing they have a signal greater than the interference or the noise floor, then they are quite happy to perform. It's when that carrier to interference ratio falls below a certain level will the radio receiver then have problems decoding the wanted information from the interference. And a C2I margin literally is how many dBs in margin do I have over my noise floor or my interference floor from my wanted received signal. So as the picture here is trying to allude to, we've got our noise floor and our interference levels at the bottom of the screen. We have our receiver threshold point, which obviously must be included in this. And then we have our received signal level. And providing the yellow line, the C2I margin, exceeds the requirement for that particular radio technology, 19 dBs for the text technology, for example, then we would predict that that receiver would function and be able to decode the information held within the wanted signal. What systems use it? Well, normally, C2I is normally used for mobile systems, GSM, 3G, Tetra, PMR. It can also be used between fixed and mobile systems where they share the same band. So if you have point-to-point links or point-to-multipoint telemetry links that are in the same band, you can actually model those and look at the interference contribution from those fixed links into any mobile systems. So setting up the ATDI planning tools. So first of all, the tool will only be able to calculate where it has coverage predictions already carried out. So one of the first things you must do, or must ensure that you do, is you set your calculation distance far enough so that the communication system that you're working with, the signal level will be predicted to the noise floor or below the noise floor even. And then within the actual parameters itself, you would want to know things like, is the antenna tilts on your wanted system and your interfering systems mechanical or electrical, so that you've got the right correct settings, and any attenuation you have between systems that are located on the same site. For example, you may well have some kind of filtering between systems on the same site, therefore offering an amount of attenuation. You would put that in there to model that. The ATDI planning tools have a number of different carrier to interference functionality. This is a screenshot of the current menu, along with the number of actual functionality in there with an outline, a very top level outline of which function does what. So for example, global interference, it determines that if any carrier or any station providing coverage to a pixel has interference, then it will show that pixel as interference. By that I mean, if you have 3 sites covering the same point on the ground and one of them has interference, then the tool will actually show that pixel as interfered with. So pretty much a worst case scenario. The next one, interference plus blessed server, is the opposite. If you have 4 carriers covering the same point, then one of the carriers is not interfered, then it will show that station number on that pixel. So that's pretty much best case. And then the other functionalities below are to do with different types of technology, different types of particular features or functionality you want to show on the screen. For example, a C2I map will show you each pixel by pixel what is the minimum C2I that is available at that point. C2I map on BAS server shows the maximum you have available between any BAS servers. Whenever you, and as I'll show you later on in the demonstration, whenever you change any of these options on this menu, at the bottom of the screen you'll see that there's a tip that gives you an indication of what that functionality is going to do. So moving on, what are the masks? What are they? These are the ability to know what type of protection your equipment will have. For example, if it's a broadcast piece of equipment, there are international agreements that says that if you are two channels off center frequency, then you will have 20 dB, say, of protection, of attenuation given to you by your receivers. Now within the ATDI tools, we can also model both similar technologies, FM broadcast, for example, DVB-T, for example, against DVB-T, against FM, and dissimilar systems. So we can actually look at what is the effect of TDAB radio 70 megahertz band. So what we have here is the selection of what type of masks we are going to use. We have 4 priorities running from NFD masks for priority 1 through C2I tables, priority 2, from the transmit receiver parameters box through to one we build ourselves, which is a priority 4. We also have other logic rules that is available to it. So, for example, if we've set out our equipment in the planning tool to be the same network ID, and we're looking to look at inter-network interference, we would check the excuse me, we would check the same network ID box so that any stations that were the same network would not be considered as interferers. Apologies there, I'm having a bit of a cough. So, NFD masks, what are these? These are normally used for modeling dissimilar equipment. So, for example, if I wanted to look at LTE upon WiMAX, because they were sharing the same band, I would bring in my power spectral density masks for both equipment and my rejection image factor for my receiving equipment. If I just swap to the IRF calc, I have an example. What we have here is the ability to look at 2 different technologies. The transmitter, the top screen, power spectral density mask, against the receiver, the middle screen, a rejection factor. And therefore from this produces me a net filter discrimination mask, which tells me that if my equipment interfere is, let's say, let's move this so that we can see, if my, excuse me, if my equipment, my interferer is 10 megahertz off co-channel, then I'm going to see somewhere in the region of 3 dBs attenuation offered me by the fact the equipment masks are dissimilar, and that part of that will come from the transmit mask and part of that will come from the receive mask. These need to be constructed prior to the use in the tool, and then each station will need to have it configured in the base station parameters. So we would set this up, and we would actually point these towards the relevant locations where these are being stored, normally the base directory where you have ICS Telecom or ICS Designer or HDZ Warfare installed. These would, upon the build NFDs, these would construct all of the transmit on receiver masks and receiver on transmit masks ready for use for selection by the tool during that process. And then within the base station parameters, you would actually go onto the NFD option on the Advanced tab and select from the drop-down list what that piece of equipment actually is, the mask for that piece of equipment. So that's NFD masks. I mentioned broadcast. There are a number of international agreements with regards to protection margins for different broadcasting standards. So if in your base station you have selected an FM stereo system or a DVB-T, then when you come to do the interference analysis, you would select C2I tables, and it would look at each station in turn, detect what type of transmission it was, and apply those protection margins from the lookup tables, which are hard-coded into the ATDI planning tools. The final one, well, sorry, not the final one, the third one is the C2I for the co and first adjacent channel from equipment parameters. And again, these would be entered on the Advanced tab of the radio equipment parameters box. On this example there, they are nonsense because I've left them at default of 0, but I would expect that you would actually put in my whatever C2I was for co channel and then the C2I value for the first adjacent channel. Therefore, this is another way of having mixed equipments so that you could actually have each one configured independently. And then the final method is priority 4, is actually entering for the co-channel, the relevant level for C2I, and then the first adjacent, second adjacent, so on, through to the 15th adjacent channel. And this ends up giving us a symmetrical curve that will model the C2I requirements for the wanted channel. You don't have to do all 15. Typically, the co-channel and first adjacent, maybe second adjacent, would give you suitable results. The other thing I said at the beginning of the chat was that we had to have coverage predictions. If the tools don't have the coverage predictions already calculated, then it can't do the interference analysis. It can also only do the interference analysis where the coverage predictions cover. However, modern systems now tend to have a wanted signal, or the coverage, or the service, whatever you would like to call it, for a large percentage of time, maybe 95% of the time, whereas interference is typically modeled at a low percentage of time, in my example here, 5%. In the real world, we would ideally like to be able to use the 95% time to model our wanted coverage, and the 5% time to model our interferer or our unwanted coverage. The planning tools can do this, and what we need to do is we need to do 2 sets of coverage predictions. One for the wanted signal using a model which is modeling the high percentage of time that we need, and another model which is modeling interference for a low percentage of time. We run those 2 coverage calculations, we save them, but for the unwanted, we actually then export them to a location on our system, on our network, on our PC, wherever. And the one thing, the tool can then tie the 2 sets of predictions together by using the call signs. So where the wanted coverage, we would typically set out our range, our service range, to be whatever we expect from that piece of equipment. And for the unwanted or the interference, typically we would set up the calculation distance to be 3 times the wanted service range. And of course, where possible, use a suitable interference propagation model, 1546, 370, Vienna, one of those. I was just going to go back, and now I'm just going to bring up the demo I wanted to do. There we are. So apologies about that while we get there. And once the screen catches up. Here I have a sample network running and I have my wanted coverage calculations, and I want to do an interference assessment between these stations to see how good or bad the frequency plan that I've constructed for it. So first of all, we select our network interference C2I mode, which is under coverage network interference C2I mode, which brings up that menu I showed you in the PowerPoint slides. And as you can see, for global interference, at the bottom of the screen, I've got displays all interference, verifies general frequency. If I make a change to my options for that, you will see that the tip of the bottom of the screen changes. So I've selected multi-channels now, and the tip has changed from displays all interference areas to verifies all transmit channels. If I was to select a different interference functionality calculation, then here I've selected interference on best server, and it tells me that it will display interference where that transmitter is the best server, and it will look at the wanted threshold. And at the moment, because I haven't deactivated or activated, selected another option, all of the stations here are regarded as both wanted signal and interferers. So if I just run with that one for the moment, and we will see, let's check the rest of the setup first. If I go into my C2I, I've got my parameters set here for my co-channel, what carrier to interference I need for my co-channel, and what for my first adjacent and second adjacent. I've checked my more options to make sure that I'll uncheck same network ID, because if I'd left it like this, what would have happened is there would have been reports of no interference, and that would have defeated the object of the presentation in the demo. So I'll click close on that. So it's always a good thing just to work through your settings, just to confirm that you have what you set, what you think you have set. And if I click start on this now, this will go away and do the calculation. It will identify where stations are best server. It will then, on those areas, it will use all of the other stations as interferers, unwanted, so it will do each station in turn. And it will then calculate where there is potentially an interference problem. When it's finally finished, we end up with a report on a station by station, giving us some information about where we have some interference, how large that interference area is, for example. And if I close that, I can then export that to an external file if I need, just by clicking on the listing button. But I'll close this for now. And this brings up onto the screen the best server coverages, and in the pink purple color where potentially I've got a problem with interference with regard to the network. Now, as I've said, this has only used the coverage prediction that is on the screen. What we need to do now is to, if I use interference analysis, use my unwanted coverage predictions, which I did using 1546 set at 1% of time. I exported them to an FDU directory, and now I'm going to utilize those in the interference analysis, and hopefully this will demonstrate the usefulness of actually using two sets of coverage predictions. So I go back in and do my network interference again, and in this time I check the coverage from FDU box, and I point the tool at the location where these unwanted coverage plots are. And now, when I repeat the analysis, this time what the tool is doing is it's using the wanted coverage, which is held on the screen, as the area of wanted signal, but it's looking to each of the other stations' corresponding unwanted file, which is stored in that location that I pointed the tool to, as the interference prediction. The upshot of that is, as you will see, there is significantly more interference coming, being predicted, because potentially in the first time around, this station 7 up here in the northeast corner is coverage prediction only goes out to about 30 or 40 kilometers. So any interference caused by that station will be restricted to within that calculation range. By using the unwanted out to 150 kilometers or so, its effect upon the network is shown to a greater distance. And also being the fact that it's using a propagation model with a lower percentage of time, the actual interference levels have changed. So that concludes the demonstration. If there are any questions, I'll be more than happy to take them now.